Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. In this video, we're going to take a look at how to are multiplying rational expressions. So let's go ahead and get started. So in case you forgot, a rational expression is essentially when you have a fraction. So P over Q, assuming that Q does not equal 0, because then it's undefined. We've talked about that before. And so what we're going to do now is we're going to learn how to multiply two rational expressions. Now in our case, we're going to be dealing with polynomials basically that are in a rational expression type format. So here's our first, our only example for this video. Let's say we have 5x over x squared plus 5x plus 6, and then we have that multiplied by x squared minus 4, and this is over 10x. So this is what we're working with. Now, we could just multiply straight across. That would be one way to deal with it. However, if we factor our polynomials to whatever potentially they can be, we will be able to deal with this much more efficiently and faster, because then we can remove terms that are in also the numerator and the denominator. We call that simplifying, as I'm sure you're aware. So what we're going to do is we're going to factor x squared plus 5x plus 6, x squared minus 4. 10x and 5x, we can kind of deal with that already, but I'm not going to. If you're more familiar with math, you probably know what to do with those. But let's just take this one step at a time. So why don't we go ahead and start with the x squared plus 5x plus 6. We're trying to factor these polynomials so that we can deal with them in a much more efficient manner. So using my favorite method of factoring, the AC method for polynomials, we know that with this first one that a dot c, whatever two terms we're going to use as factors, is going to be 6. Is going to multiply to 6, because x squared, that's basically 1 times 6 is going to be 6. And then a plus c is going to equal 5, because that's our middle term, the b term. So as I look at this, the clearest way to address or to deal with this is to do the following. X squared plus 3x plus 2x plus 6. Now, why 3x plus 2x? Well, 3 times 2 is going to give me 6, and 3 plus 2 is going to give me 5. That's how I know this works. And so we group like so. So I bring the 2 out front. I have 2 and then x plus 3, like so. And then over here, I put the x on the outside, and I have x on the inside plus 3. That leads us to the following. We have here basically x plus 2 and x plus 3. This is our new factored, if you would like to call it, denominator here. So I'm going to write this on a separate screen so that we don't get too confused here. So we got 5x, and then we have on the bottom, we have x plus 2 and x plus 3. All right, let's go back. Now, for our second guy here, we're going to be dealing with this x squared minus 4. Now, it might look like you can't factor this, but, you know, again, if you look a little bit more carefully, there is a way to deal with this. Again, following the AC method again, we want something where a times c is going to equal negative 4, and a plus c is going to equal 0. Why 0? Because there's really no b term here. So we could put like x squared, you know, plus 0x or whatever, or minus 0x minus 4. We could do something like that. But whatever we do, it needs to make sure that it comes out to negative 4 here when we multiply it. So put it on our thinking caps here. What's clear is that the middle term needs to cancel itself out. It needs to be a positive number and a negative number. And so the easy way to deal with that, if you just look at the end game here, how we're going to address this is the following. X squared plus 2x minus 2x minus 4. Now, what's happening here? Positive 2 plus negative 2 is going to give me my 0, like we need over here. But then 2 times negative 2 is going to give me my negative 4. And so this is the factored out answer, or almost there. We're almost there. There's a few things we have to do first. So I bring out my negative 2 here. I'm doing this part right here, excuse me. Negative 2, so x, and then plus 2. Because negative 2 times positive 2 will give me my negative 4. And then now if I deal with this, I'll bring the x on the outside. I'll have an x plus 2 again. So that brings us to our final answer, which is going to be right here. Let me put it in a slightly different color so we don't get lost too much. It'll be x plus 2 and then x minus 2. That is our numerator for the second one. So I'm going to go ahead and put this over here. So x plus 2, x minus 2, like so. Okay, now the rest of this is going to stay the same for right now. So then we have the 10x like so. Okay, so now we have our factored out answer, if you will. Now we could consolidate this a little bit more. And so essentially I would have the following, if you will. I would have 5x, and then I would have, I would have x plus 2, x minus 2. And then down here at the bottom, I would have 10x, and then I would have x plus 2, x plus 3. X plus 3, yes. All right, so here's the first thing. The 5 becomes a 1, the 10 becomes a 2 because they simplify like that. The x plus 2, they cancel out like so. And so now I'm left with the following, if you will. So this will be reduced down to, let's see here, 5x. Yeah, this is gone too. So this will be reduced down to, looks like x minus 2 over, let's see here, 2x plus 3. And so we distribute the 2, and we're left with the following. X minus 2 over 2x plus 6. And we're essentially done right here. We cannot reduce anymore or simplify anymore the expression. So this is how the process works. All we're doing is that we're factoring, and then we're remembering the rules for simplifying fractions or rational expressions as accordingly. That's all that we're doing here. So we're just adding one layer to what we learned about, what we learned about dealing with factoring and dealing with polynomials. So let me go back and try to explain as a recap what we did here. So we started with this guy right here, this rational expression that are multiplied, 5x over x squared plus 5x plus 6, and then x squared minus 4 over 10x. We're multiplying that. And before we just multiply everything straight across, which is what you would probably do with just a regular fraction type problem, we decided to factor whatever was possible. So x squared plus 5x plus 6 could be factored, as well as x squared minus 4. And we used in particular the AC grouping method to try to address that. And so by doing that, we were able to come up with the factor terms that we have right here, x plus 2, x plus 3, and for the numerator in the second expression, if you will, x plus 2, x minus 2. And then it's just a matter of removing like terms. So we had an x plus 2 above here, x plus 2 in the denominator, that was removed. And then we had the 5x here in the 10x was removed to 1 over 2, like so. The x minus 2 and the x plus 3 remained for a while. And this was almost our final step. And so all we had to do here is we had to address simplifying the denominator, and we were able to get our answer. So again, this is not that complicated. It's just adding one layer of complexity to what we already know about factoring. So I hope this video was useful for you and you were able to understand the topics that we addressed here. My name is Darren Thomas, and I am the Director of Educational Research Techniques. Take care.